and then see which one it is. Like for the first one, the carbon has how many electron groups around it? 4. So the type of hybridization would be sp3, right? Remember that connection? sp3, and then this carbon would be how many electron groups around it? 3. So the type of hybridization would be sp2, and then this carbon would be how many electron groups? 2 electron groups. The type of hybridization would be sp. Okay, and which bond do you think will be the strongest? Single bond, double bond, or triple bond? Which one do you think will be the strongest? Triple bond. Kind of make a guess there, right? There's more interactions between the 2 carbons, right? There's 2 more pi bonds. 2 pi bonds, 1 sigma bond. So the interaction is stronger. And yeah, so triple bond will be stronger than double bond than single bond. What about bond length? If you were to predict the bond length, which one do you think will be the shortest? If you were to make a guess. Would the strongest be the shortest? The strongest would be the shortest. You can think that the electron densities are higher in between the 2 carbons, right? There are 6 electrons. And then the interaction, or the electrostatic interaction between the bonding pair electrons with the nucleus of the 2 carbons will be stronger, because there's electrostatic forces holding the electrons, interactions between the electrons and nucleus of the carbon. So that interaction is stronger. The triple bond will be the shortest and the strongest. Just want to point out that one. What about bond order? Do you remember the bond order? Like triple bond order would be just the same with the type of bond usually. Triple bond would be, bond order would be just 3. And then double bond would just be 2. And then single bond would just be 1. Remember the bond order for benzene then? Like carbon-carbon bond order for benzene? Because remember, this structure can resonance, right? So all the electron densities around all 6 carbons are the same. So if you were to resonance, each carbon-carbon bond is an average between single bond and double bond, right? So for that case, how would you say the bond order would be? If it's an average between double bond and single bond. And you can have decimal places. That'll just be 1.5, right? 1.5. So for this cases, it'll be 1.5. For some of the resonance structures, you also have decimal places. It's just gonna be an average between single bond and double bond. All right, so I'll leave that. And then let's start with our problems. We can just start from the multiple choices and see what we get. And we can go over multiple choices once we're done with that.
Actually, no, just because it's below the 30. Yeah. I don't know.
We can check with each other when we're done for the multiple choices.
What?
This one, beryllium, is the only one, like the exception, right?
But that's less than octet.
Right.
You want something that.
The only ones that can do that are the noble gases, right?
No, it's the third row or above.
Okay.
Are we done with page 1?
No.
Okay, take your time.
But it is it C?
Yeah.
Because it's.
Oh, no. Actually, that one. It's tricky, right?
Yeah.
These problems are not as easy. These are the harder ones.
So why would it be?
Because you want to minimize FOMO charge.
Oh. So you want 2, but you want less atoms to have a charge.
Yes.
Okay.
And the plus sulfur can expand, right?
This is 0, this is 0. That makes sense.
All right, I'm going to wait for you to finish the first page, and then we can talk about it.
There should be 32. We need 32 because
Are we done with page 1? First page? Good. So let's go through it together. For 1, which is the correct answer?
C.
C, right? C. You have to draw out the Lewis structures. Make sure you count the number of electrons right. I would say the safest way is to go through the list of rules we had. Overall number of electrons, do your skeleton structure, put the least electronegative atom in the center, make a single bond, and then place out lone pairs on the atoms around, and place extra lone pairs for the center atom, and then check if everyone has an octet. Make a double bond as necessary, and see if you can expand octets, minimize formal charge, like all those lists. I think it's safe to do that, and then so you have. I saw some of us just had that and picked the B, and if you count the number of electrons, iodine is missing a lone pair, right? So, and if that is the case, that's how many electron groups around iodine? 5. So 5 electron groups. That means the type of hybridization has to be sp3d. To take one s3p and one d orbital and hybridize them together. All right, so the second one we just talked about, that's like being able to draw out Lewis structures for ABC and identify there's single bond, double bond, triple bond in between the carbons. And then we know that single bond will have the longest bond length, right? What about 3? So which one can expand octet? B, right? So B. So the rule here is your element has to be in the 3rd period or above, right? 3rd period or above, because you will have 3d orbitals there to take extra electrons. Because for 2, like when the principal quantum number is 2, or for your 2nd period, there's no 2d orbital to take extra electron. So, and if you remember, some of the phosphorus, sulfur can expand octet for some of the commonly structures we drew out. So it has to be B. Well, for beryllium, it's the one that less than an octet, right? Beryllium and boron are less than an octet. And then for 4, it can be a little hard. Just follow the rules. Follow the rules. The first structure you drew out when you follow the rules is gonna be A, right? It's gonna be A, and we say that when an atom can expand octet to minimize formal charge, minimizing formal charge is more important. So this is one of the cases. And if you look at the formal charge for all the oxygens, they are, for all the oxygens, remember how to do formal charge? Number of valence electrons, subtract the number of electrons atom owns. For all the oxygens, they own how many electrons? 7, right? So all the oxygens have -1 in this case. And then the sulfur would have formal charge of +2, right? +2, so 6 minus 4. Because you know whenever atoms are charged, the energy is higher. So if you minimize charge, so the ideal case is like if you have 2 minus for the ion, you want to have only 2 atoms bearing like a -1. So to minimize formal charge. And the sulfur can expand octet, right? So we want to make double bond as needed to minimize formal charge for the overall structure. So the actual, the correct answer would be, if we can make multiple bond to minimize formal charge, correct answer would be, which one?
B.
B. So correct answer would be B. So this is a little hard. Yeah, so that you only have two atoms that can bear -1. And sulfur has like 12 electrons around it. All right, so the next one for 5, which is the most polar, which is the, which one? B, right? So we know fluorine is the most electronegative. What about for 6? D, I heard D. Agree? So if you draw a Lewis structure, and you know when you have 5 electron groups, all the lone pairs will be on a equatorial position, right? Either 1, 2, or 3. So the electron groups would be trigonal bipyramidal, and then your molecular geometry would be linear. So just gotta be familiar with Vesper, like the electron geometry and the molecular geometry. All right, for 7, which one? B. Yeah, so carbon, when it has a double bond, it's sp2. So this one is easy. We just kind of practice on this, right? All right, are we all clear? Let's move on to the second page. If you're done, you can just keep on going forward. this last multiple choice, satisfying octet root is more important. Just keep that in mind.
So it's a little funny. So are we mostly done with page 2? Page 2 done? So I can check. We can check, just make sure you have the correct number of electrons. The first place, some of you had 16. minus charge, make sure you add one. And then none of these 3 atoms can expand octet. So make sure the central atom has fulfilled the octet rule. You don't want to be overcrowded. Like if you make 2 double bonds with oxygen, it'll be overcrowded, right? Because it also has a lone pair. And yeah, so there will be resonance structure because there's no reason that one oxygen would get a double bond, not the other one. Just follow the list of rules. You should get this structure correct. Do we have any questions for this Lee structure? If you got the right Lee structure, then you have the right electron group.
What's the correct answer for number 8? Up at the top.
Oh, I forgot about it. Okay. So that one. So for this one is also a little tricky. It's a little hard. You just have to fulfill octet for this. So fulfill octet is more important than bearing formal charge in this case, carbon monoxide. If you fulfill octet, what's the formal charge for carbon? 4 minus 5 minus 1. Yeah, so for the other Lewis structure, I know last time I mentioned fluorine doesn't make double bond, right? If you think about it, most of the halogens don't really make double bond because they're very electronegative. They don't want to give off electrons. And I think through practice homework problems, you should always, you should also see that. So theoretically, you could make one extra double bond here, but the real Lewis structure is actually 3 single bonds to chlorine. Just comes with practice. And then, yeah, so if that's the case, let's see. So that this will be the correct Lewis structure, and then make sure we have the formal charge. So formal charge for nitrogen here would be how much? 0. And for this oxygen to the right would be 0, because 6 minus 6. For this oxygen to the left, it will be minus 1. So that should match up with the overall charge of minus 1. In this case, for the structure to the right, all atom has like a 0 formal charge, right? 0 formal charge. And for the geometry, yeah, you could just use dash to point out the bonding atoms or the lone pairs, as long as you have the correct bond angle. Like in this case, you have how many electron groups around nitrogen? 3 electron groups. So you know the electron geometry should be like a trigonal planar, and then you want to draw like a trigonal planar. Or if you just want to draw out like the molecular geometry, that's fine too, because it's as molecular geometry. But make sure you indicate like the correct molecular geometry right there. If you want to draw like one of double bond, that's fine too. Just make sure the overall geometry, bond angle is correct. And when you have 5 electron groups, we mentioned that it can be tricky to know where to put that lone pairs. They always go to the axial position, equatorial position. So if the 2 lone pair goes to the equatorial position, the molecular geometry is going to be a T shape. So that is like how familiar you're with the Vesper theory, right? And yeah, so based on that, if it's a T shape, is it polar or not? It's polar, because these 2 cancel off each other. And we don't worry about lone pairs when we decide the polarity of the overall molecule. So the net dipole should go to that direction, right? It should go to this direction. Did keep on going with the problem set. You guys want to quickly go through this second problem because we don't have much time. All right, so for A, the bond angle for this structure would be, what is the bond angle? 120. So you have to decide the electron geometry first, right? Always electron geometry first, which is trigonoplanar because you have 3 electron groups around each nitrogen. And then if it's trigonoplanar, 3 electron groups, what's the hybridization for nitrogen? sp2. Just with the given Lewis structure, the number of sigma bond would be overall 3, right? 3. It's this. Every time you have a single bond, there will be 1 sigma bond. And then you have a double bond, there will be a sigma bond and 1 pi bond. And then that's another sigma bond, 3 sigma bond. And then 1 pi bond. And then for the structure to the right, approximate, so the molecular electron geometry would be 6 electron geometry would be octahedral, right? So octahedral and square pyramidal. So you have 1 lone pair. So the molecular geometry would be square pyramidal, right? And what is the bond angle for that? 90 degree. Yeah, 90 degree. Hybridization for that, 6 electron groups. sp3b2. And then in this case, there's only a single bond. So there's 5 sigma bond, no pi bond. Right, is that clear? So yeah, I think overall this unit is easier, relatively easier. Like I had another question which is more important, fulfilling octet or minimize formal charge. So if it's, if it cannot expand, if your atom cannot expand to more than 8, fulfilling octet is always more important. And if you can expand, you can minimize formal charge from there. I'll still give you a study guide. I would say review from working through problems. Like you can always take out all the blank worksheets on Canvas and redo those problems as well. All right, I'll send you an email.
Can I do it right now? Do you have a question now? Okay, perfect. I'll wait in front of the office. Thank you.
Can you punch an answer key to that?
Yeah, I will do that.
Perfect, thank you.
No
Are you gonna post the answers to the 3
Yes.